It is very important to identify and understand the different mortars, plasters, and renders present in a building, both to conserve them or to design compatible new ones when necessary. The materials, composition, and technologies varies around the world, depending on availability of materials, climate, and local construction culture. Sometimes they are considered a sacrificial part of the building, but every effort should be taken to conserve them when possible, and in a suitable way for the conservation of the whole building. Mortars bond the masonry units. They are the bedding agent to take out irregularities in masonry, events out loads distribution, and transmit load from block to block. They contribute to flexural bending strength of masonry. They play essential role in behavior of masonry in compression, and thick mortar joists may cover possibly a weak brick, falsa cortina. Lime and gypsum are the binders in mortars and plasters. The selection of the right binder is important and has to be made in accordance to the specific substrate, required strength, environmental and climatic conditions. Mortars should always be softer than the surrounding stone or brick of the masonry, otherwise they will accelerate their decay. Lime mortars are composed by binders, lime of hydraulic lime, which are able to set in the presence of water. The fillers are sand, should be washed clean to remove salts as they cause efflorescences, clay or organic material slowing the hardening process. Water is also an important component, and it should be an accurate mix ratio of lime and sand as well as water content. It is also necessary an appropriate elaboration and post-application curing. Lime is the most extensively used binder in traditional buildings. Thereafter, its understanding is vital for successful conservation projects. It is necessary to be aware of the lime cycle. It starts with limestone, which is calcined, and water added to produce quicklime. This is a slaking water, and when it enters in contact with the air, it becomes again calcium carbonate. Gypsum was used in Egypt from 3000 BC, both as a mortar between blocks of stone in the pyramids and as a plaster. Gypsum mortars and plasters are prepared by heating at moderate temperature gypsum minerals or selenite rocks, both composed of hydrated calcium sulfate. The existing mortars should be analyzed in order to conserve it or specify the mortar to be used in the conservation works. This should be compatible with the original mortar. Please read the Technical Advice Guide by the Scottish Lime Centre Trust on Materials Analysis and Matching. It is necessary to carry out stratigraphic essays to investigate plasters, finishes, and paintings. Progressive removal of material starting from the most superficial layer allows for the investigation. This is a specialist work to be carried out by a conservator, using a scalpel and other suitable tools. It is important to identify the various phases of a building and to decide the final material and color to apply. We should not confuse the stratigraphic units and the gradation. Samples should be taken for laboratory analysis on the composition, porosity, and condition. Typical pathologies indicating plaster decay are blistering, cracking, flaking, and detachment. Typical failures in external render are due to human factors and poor workmanship, for example, a render too thick or too much water in the mix, oversaturated backgrounds, and insufficient setting between coats. The color can be investigated by taking thin sections. Some important considerations are that the mortar should always be weaker than the surrounding masonry. In saturated masonry, the lime will be leaching, provoking the accelerated decay of mortars and stone. Soluble salts in the masonry will produce pathologies such as pitting and spoiling of the surface, white bloom, and the consequent breakdown of the mortar. Water splash from roads with salts will also damage lime mortars and stone.